Alright, how's it going, y'all? Today, we're going over the 5 most common mistakes I see new people making whenever they're setting up a UniFi deployment. So this ranges everything from just messing up geo-blocking all the way into some things that'll actually slow down your network because you're using ports on routers that are really meant to be routing rather than actual switching. And this is just going to go over the most common 5 mistakes that I see people make, and they're all pretty easy to resolve except for 1 or 2 of them. And by the way, if you'd like to hire me, there's a link for that down in the description below. I do setups like this all the time. And in general, UniFi makes it very easy to set up a very solid network. And quite honestly, none of these are super issues that are just going to absolutely cause massive security issues or anything like that. UniFi has a great secure by design setup in general, and you have to go pretty far out of your way to accidentally mess up and really make something insecure. But a lot of this can be things that will make your spouse have a huge headache and just cause other issues like that, and even slow down your entire internet connection unnecessarily. So the very first one on the list is by far the most common one I see, and also happens to be the only real thing on this list that is actually really hard to change. And that is when you're setting it up, you are using the wrong default subnet. And if you look right here, I am actually doing it. So number one is that you are still using a default subnet of 192.168.1. I see this all the time, and I actually really would love to see UniFi just change this to a random subnet by default, because this can cause you issues down the line. So there's 2 parts of this that make it a big headache. First, the auto-scale network feature. I am not a huge fan of that because if you auto-scale a network and you don't have everything set up with DHCP, then all of a sudden devices are randomly not going to be able to communicate with each other. So in general, I turn that off. If you need a bigger subnet, you can absolutely allocate yourself like a /23, and now you've got 500 usable IP addresses. But that's not the issue. The issue is this right here. So if you're not super familiar with subnets and networking, essentially whenever you're doing a /24, which we're going to keep for basically this tutorial just to make it a lot easier to understand, whenever you're dealing with a /24, the first 3 octets of the IP address say what network it's on, and then the last digit is essentially what that address is on that network. I'm going to leave a link down in the description below to a subnet calculator. It helps a ton understanding this if you're not using /24s. And any time you're setting up a local area network, you should pick one of 3 different subnet ranges that are designed for local area networks. 192.168.anything, 10.anything, or finally, the confusing one that's not a regular digit is the 172.16, and that is what's called a /12 network. That one's a little different, so I tend not to recommend people use that because honestly, it can just confuse people very easily. And so as you can see, by default, it's using that proper subnet. So we're seeing that anytime we start a local area network with 192.168 or 10, that is guaranteed to not exist on the internet. And that is actually what these are designed for. They're designed for local networks that you can allocate however you want to, and so you want to make sure you're using one of those, which is what's going on here. The problem is 192.168.1 and 192.168.0 are by far the most common subnets out there. So most routers, when they turn on and are set up by default, use this exact same subnet. And so if you're just working only in your local network, that is not a problem at all because it's not reaching out. The problem comes down to whenever you're using a VPN. And inevitably, you're going to want to use a VPN for one reason or another. And I'm not talking about like NordVPN, like a privacy VPN. I'm talking about a remote access VPN. Eventually, you're going to want to be able to securely access things on your local network, not on that local network. So for an office, you may end up with a second office, and you want the 2 offices to be able to talk to each other. The problem comes down to, if these are not unique, you start having trouble. So if I set up a VPN server, and I'm at my house, and my office network is at 192.168.1, and my house is also at 192.168.1, now my packets do not have a clue how to get to their destination, and everything breaks. Same thing, you can't set up a site-site VPN. It causes a ton of issues. So the very first thing I recommend every single person do as soon as they install any new router, and this is regardless of UniFi or whatever router you're using, always change this. And the way I generally like to work is I assign every single site a 10 dot something network. So I'll basically say, hey, anything on this router is going to be 10.120. And then every single VLAN I create will start with 10.120. So in this case, I think I did choose 10.120.20. So you can see I've already set up for each of these VLANs right here. And the first thing I want to do off the bat is make sure that every single one of them is that. So I've chosen for this one 10.120. So now I can do 10.120.1. And the reason this is useful is it's really unlikely that anybody else is going to have 10.120.1. It's technically possible, but it is really unlikely compared to using something like 192.168. anything realistically. So that is what I always like to do, because now down the line, when I set up my VPN server, it's really easy to route traffic because the VPN server will essentially look out for any traffic going to 10.120.1 and just route it through the VPN. And unless you're somehow also at a place with 10.120.1, you're not going to have any trouble. Same thing if you're in an office and you eventually get a second office. Maybe that second office, everything starts with 10.130. And now you can set up all your same VLANs, and because they have that separate subnet, you know there's never going to be any kind of conflict. One thing to note, when you do this, you basically will have to restart all the devices on your network, because now, if they were using that 192.168 IP address from earlier, that's no longer going to work. And so that's why you want to do this early on, because you will also have to reset up any kind of DHCP leases. And if you've assigned any static IP addresses, i.e. IP addresses not assigned in UniFi, make sure to update those first to DHCP. But that is by far the first thing right off the bat we're going to do. And essentially what I would recommend doing is just pick a value for every site between 1 and 250. And that is going to be the kind of site identifier, as I like to call it. And then just choose your network like this. And this one just is 120. All right, cool. So I'm going to go ahead and hit apply changes. And we'll see that our switch is probably going to be broken for a little while because it was originally on 192.168.1.30. Luckily, UniFi stuff all does communicate and it'll figure itself out in a minute here. Finally, any devices that do continue to have weird issues, easiest thing to do is one of two things. If you don't want to turn it off, you can normally just unplug the Ethernet cable, wait about 5 seconds and plug it back in. Or easiest thing to do is just reboot all the devices. When they reboot, they're going to pull a new IP address, and that IP address will be in that proper 10.120.1 subnet. And so you can see my USW Flex XG went ahead and now has pulled that 10.120.1 subnet. And so now it will work again. But definitely do this as early on as you can. And this is true for every single routing setup you ever do, because the sooner you do this, the less headache it's going to be. And eventually you're going to need to do this if you ever want to set up a remote access VPN. All right, so that was number one. And a quick 1.5 is the flip side of this, where you're actually using a non-reserved IP address for your subnets. So I have seen people use 11 dot before for their local network, and 11 dot is a valid IP address on the internet. So never use anything for a local area network that does not start with 192.168, 10 dot, or the 172.16 to 32 subnet. Because if you do that, all of a sudden, websites on the internet that are valid, that happen to use that same IP address, will just break everything. So definitely avoid doing that as well. All right, so now on to our real number 2, and that is geo-blocking. And this is something I see all the time because it causes the weirdest annoying issues out there. So under security and then protection, a lot of people like to go ahead and set up region blocking right here, and they do it extraneously. So region blocking does exactly what it says. It essentially looks up the IP address of any incoming or outgoing connection and blocks it if it's on a predefined list. And there's a couple of ways to do it. You can either do it on an allow list, which is incredibly restrictive, where you can say, hey, I only am going to allow this and this to come on in. Or what's more common is a block. Then once you've selected that, you've got two options. Well, three. You can either do both directions, outgoing or incoming. I will see it fairly often where you come in here and there's like 30, 40, 50 different countries selected in here, even like Germany and very common countries that are actually used, and people are having weird internet issues. And the thing is, if you block a ton of these countries, you're going to have issues where now if you try to go to a website that happens to have a server allocated to that IP address, it's just not going to work. And so if you are going to go region blocking, I recommend keeping it to only about 3 or 4 countries that you know are not trusted and you really do not want to touch. And another thing you can do as well is, instead of doing it in both directions, make it incoming only. Incoming only basically means that your devices can reach out to those websites that happen to be hosted there, and they will not be blocked on the reply. If you do both directions and you're blocking a country that maybe happens to have an update server that you need, your update's just not going to work. And you end up with a whole lot of issues like this. So definitely do 2 things. Use this sparingly, because quite honestly, region blocking does not do a ton for you for real security, because it is trivial to get a VPN and pretend like you're in whatever country in the world you want to. And in general, the countries that do the most spamming, from my experience, it is Russia and China from what I've seen. It's all very low effort password guessing. It's very basic, like rattling the door like, hey, is this thing locked? And so as long as you don't have very, very, very poor security posture, it's probably not going to do that much. And if there is a real vulnerability on your system, they're probably going to be exploiting it using a VPN to appear in whatever country in the world they want to. So this does not help a ton, other than really just limiting spam in some cases. Another thing is, there are a whole lot of IP addresses on these lists. They don't all come into nice and pretty subnets. So as you add more and more countries to this list, your internet traffic actually starts to slow down, even in a really fast router, because it has to match a whole lot of different subnets to every single packet to make sure it's allowed. So that's another thing that can happen, is you can really start to have a higher latency, even on a very performant network, because of this. So in general, just recommending limiting this list as much as possible and only using it if required. I generally don't even recommend having it. And then if you want to keep it even lighter and easier, you can have it as only incoming connections, or both directions. Tends not to have too much trouble if you are using the both directions options. But you can also very safely just turn this off, as in most cases, it's not going to do much to you from a security perspective. Your intrusion protection right here is going to do so much more. Having intrusion protection on with notify and block is going to be so much more powerful, because it's actually going to look at known bad IP addresses and block them, rather than just arbitrarily blocking countries of origin. So that is number 2, is just using geo-blocking, quite frankly, unnecessarily. All right, so on to number 3, I actually have some props. All right, so number 3 is another one of those ones that's really more of a headache than anything else, and it's just going to cost you extra money and maybe a little bit of downtime versus actually having a true security issue or anything. And that is that you are using the wrong cables to do uplinks between 10 gigabit ports. So a lot of UniFi switches and a lot of servers, when they're using faster than 1 gigabit connections, they really default to fiber SFP+. And that is because of this cable right here. This right here is a SFP+ DAC cable. DAC stands for direct attached copper, and they can be up to either 3 or 5 meters depending on the protocol. And that means that you can have a SFP+ connection, not require expensive transceivers converting your signal to light and back again. Instead, with a short run, you actually can just go straight over copper, which is much, much cheaper and honestly more resilient to issues, because it's really hard for these things to get messed up. SFP Plus does not require nearly as much complex compute as a 10 gigabit RJ45 10G base T connection does. And so they produce less heat and they cost less to produce. And because most server racks have a single top of rack switch that everything connects to, they can just use these very cheap and very resilient DAC cables. I have seen tons of instances of people going and having very short runs and buying fiber optic transceivers and using a fiber optic cable like this to connect in between them. It is one of those things where if you want to learn about how fiber works, it's a great way to do that. But fiber is a pain. Fiber can have so many more problems than a dummy DAC cable does. And DAC cables are actually technically faster if you're looking at the nanosecond level, due to the fact that there's actually a lot of complex math that has to go on in here to convert something from an electric signal to an optical signal. Whereas DAC, it's just straight on through. So while very few users will ever notice, there's just very little reason to ever have a short run of fiber optic cables between two transceivers, except in one specific instance, and that's actually in an electric circuit breaker. Fiber optic cables actually have a very interesting advantage over electric cables because they do not conduct electricity. So if you're worried about having an exterior run cable, maybe you've got a camera outside or something that's run underground, if you're worried about that being struck by lightning, you can actually electrically isolate it by using one of these cables. This is not going to transmit any electricity no matter what the voltage is to a reasonable level. So what people will do, and I actually recommend if you're doing outdoor runs and you've got expensive equipment, is you can actually produce a outdoor only switch. So basically the switch is still with the rest of your equipment, but all of the electric runs go directly into that. Then you put it on its own surge protector, and when you uplink it from your outside switch to your inside switch, you use this kind of setup. Because now, even if that outdoor switch gets a massive voltage spike, it is at worst going to fry itself and anything connected to it, but it's not going to be able to go down that fiber optic line. And so that is the only time I really recommend that. Otherwise, definitely check out DAC cables. They are a lot harder to break, they're a lot cheaper, and they're a lot easier to use in general. Another thing I see people use that also causes even more issues is instead of using a actual SFP Plus module, they convert the SFP Plus module to Internet or Ethernet RJ45 copper cables. Those are very expensive, have a lot of power draw, and I've seen people have tiny connections in between them, whereas this DAC cable will do so much better and have just honestly fewer issues down the line. Even really high quality SFP Plus to 10G base T Ethernet transceivers draw a lot of power, and while UniFi switches in general do have that kind of power budget for the SFP Plus modules, other switches might not, and they can easily cause a headache, especially if you're doing more than maybe a 10-meter run. I've seen a lot of issues in the past with that. So that's the other kind of piece of this, is really check out and think about what cables you're using for all these things. Fiber is great, and I actually use fiber in my back server room over there so that I can easily have a long uplink that goes through a ceiling tile from my main network to my kind of network distribution switch. But other than that, everything I have are DAC cables because they are cheap, easy, and resilient. And so that was number 3. It's nothing that's going to cause you to get hacked or anything like that, but it is something that can easily lead to extended outages compared to just using DAC cables and cost you money unnecessarily. I'm gonna go ahead and put my props back, and we're gonna go on to number 4. All right, so number 4 is actually a great one because I am actually guilty of it in this exact setup right here. And that is that I have not put my upstream router in what's called pass-through mode. The easiest way to tell this is to come into your network internet settings right here. And if you look, we can see that my primary WAN, its IP address is 10.30.0.194. What this means is I do not have a public IP address. That means that doing things like port forwarding and other things like that will not work, and I'm dual NATed, which can cause other weird issues. In this case, this is my demo unit that is just for this tutorial. So my actual UDM that I'm using has the public IP address assigned, and I could actually assign, I've got a block of 5. I could assign one to this if I wanted to, but then I would be showing all my public IP address. But this right here is something that will cause you weird issues and can cause just services not to work very well, especially things like Xbox Live and other things that kind of expect port forwarding. So if you ever want to be able to like set up your remote access VPN, if you don't have a public IP address assigned, you're going to have a bad time. So some people are not going to be able to get a public IP address because their ISP does not provide them with a public IP address and instead uses what's called carrier grade NAT. There's a long story here, but essentially the world has run out of IP4 addresses. And so newcomers to like the ISP realm don't have enough public IP addresses to give every single one of their clients one. And so instead we have to do this where essentially you and everybody in your apartment may only have about 5 different public IP addresses that are all pooled and shared. If that's the case, you're not able to do this. But especially in the United States, most ISPs will give you one. And so what you should do is if your IP address starts with a 10 dot, a 192.168 dot anything, or that 172.16 up to 31 range, that means that you have a local IP address assigned to your public port on your Dream Machine. What you then want to do is you want to log into your router and look up how to set it in what's called pass-through mode or bridge mode. Every single router has its own way of doing it, and it can be a pain sometimes. But what you want to do is you want to make sure that your router that you're actually using, you want to make sure it's assigned a public IP address, which gives you full control to do everything. So if possible, definitely go ahead and do this. Though note, some users, like users of Starlink, will never be able to do this. I think the business plan will let you, and it's not really strictly required for some things, so don't worry about paying a bunch of money for it if you don't need it. But if you are having weird issues and you ever want to do port forwarding, you will need a public IP address. All right, so for number 5, it's actually a really common thing, and this is where it's nothing wrong, it's just unnecessary. A lot of people feel like everything has to be on its own VLAN, and they need to put all their devices on IoT devices, like even everybody's cell phones on the IoT VLAN. And honestly, unless you're running a massive Fortune 500 company, VLAN segmentation probably is not that necessary for you, except in some instances. So it can be really useful, especially if you've got a large enterprise, to keep IoT devices, like fish tank sensors, on their own separate VLANs that are not trusted to the rest of the network, especially if you're running a lot of servers that just fundamentally are not as secure as the rest of the network. It's very common for businesses to have servers that may or may not have vulnerabilities. And so a really great way of kind of protecting them is to have them on their own isolated VLAN that nothing else can talk to, except the very specific protocols that are required. Even if you don't have vulnerabilities, that's just good practice for people who are building big businesses, and it really can help with some protection. There is a true story about a casino who got hacked because a fish tank sensor got hacked, and it happened to be on a LAN that had a whole lot of access and was able to exploit some vulnerabilities. So that is where VLANs are really useful, is in those large enterprises. But unless you're running servers, there's probably not much on your LAN to really even hack into. Even Synologies and other general file servers are pretty resilient in general and do not necessarily require being on their own isolated VLAN. It can help, but it also has some downsides. So what a lot of people feel like they need to do is put every single device on its own isolated VLAN. And while that can help with your security, it also can make those devices not work. If you're putting your Apple TVs on your IoT VLAN, you've now got to make sure you've got the right firewall rules and multicast DNS settings to make sure that AirPlay works. And you're going to have a lot of things like that, while if you're learning networking, it's a great way to understand how firewall rules work. But it can also cause a whole lot of headaches, and you can spend a ton of time and quite honestly be 0% more secure because there wasn't really a big problem from the beginning. So while VLANs are really useful for security for larger businesses, most home users will get negligible security benefit from them. Realistically, the only time you get them is if you do have services that you're running and you're playing around with. And that's where there's a whole lot of learning opportunities there. But you don't have to have VLANs to have a secure network in general. And on the flip side of this, if you do have VLANs like IoT VLANs, you also then need to make sure you've got firewall rules that actually are restricting access between them. Because just because they're on a separated VLAN, if the default rule is allow all between them, you've not made yourself much more secure at all because you're not actually blocking those connections. Remember, that is what VLANs are for. VLANs are for making sure that you can restrict access and only allow specific things to communicate between them. If you have an allow all rule, you're pretty much not doing anything for your security. And while it is useful to have allow all rules in massive campus enterprises where you want to be able to route traffic between buildings easily, it's not necessary at a small business or even a medium-sized business level. So in general, if you are going to use VLANs, make sure you're actually setting up firewall rules, and also don't feel like you have to have a secure network. All right, so those were the 5, and I want to quickly kind of get another prop to show a bonus 6th one that kind of helps show one other common thing that people don't fully realize and will actually cause a performance bottleneck to occur in a network. And so let me just grab my router that we're going to use as a demo for this, and we'll come back and have this bonus 6th one. All right, so for a quick bonus one right here, and I'm actually funny enough doing the exact same thing I told you not to. I ran out of DAT cables for this demo. This is actually a very common setup I see with people where essentially they're plugging both of their switches into the two 10 gigabit ports on the Dream Machine right here. So this is not going to cause any kind of really routing issues or anything like that, but it actually can create a bottleneck. So the UDM at the bottom right here, this is actually the max. It is first and foremost a router. So these two ports right here are not like the two ports on these two switches. They are actually designed to be for routing. They are actually hooked up directly to the CPU and has to go through the CPU. And that's important for routing and making sure that traffic can be blocked and other things like that. However, let's say that my NAS is hooked up to this top switch right here, and everything's on the same LAN as the bottom switch right here. And basically, I've got these two ports set to both be LAN ports on the Dream Machine. Well, now I'm going to run into an issue because now my high throughput traffic can actually be bottlenecked because the UDM is not optimized to be a switch. These ports right here are not optimized as much as these two ports are on a regular switch because they are designed to do more. So by having this setup, you can actually run into a bottleneck because anything communicating from this switch to this switch, assuming they're on the same LAN, will also have to go through the router and will not be as fast. Instead, what I really recommend doing is the two ports on the Dream Machine should really be reserved, one for WAN, one for LAN, if you're going to be using it like that. In an ideal world for your fastest throughput setups, have everything go through that one LAN port, unless you truly do want to have them on separate VLANs, which is its own thing. But this is a really common thing that I see people make. The faster setup would actually be this. Now, traffic flowing between the two switches goes directly between them. Traffic from the top switch still has to flow through the second switch to get to the UDM, which technically could be a bottleneck, but it's a very rare for that to actually be the bottleneck, considering how if it's going to that, it's probably going out to the internet, and so that means that you're probably not going to have too much of a slowdown. The ideal way of doing this would be to have a top of rack switch, that's an aggregation switch, that all of these plug into, but this will still be much faster in most cases because now these two switches are able to really have that like layer 2 ultra low latency without having to go through a router. And that is just because these two ports on the Dream Machine are not regular switch ports. They're designed to do more, and so because of that, they will be slower at switching than an actual switch. So in general, if you want highest performance possible, realistically, you should only have two cables going into your Dream Machine or your router. One for your internet and one for your local network, and have everything else go through switches on those levels. All right, so that was this bonus one right here. Another one that can just cause slight performance slowdowns, and I see really common, especially people love to plug their NAS directly into the router, which will really just cause overall slowdowns when you're trying to hit those 10 gigabit throughputs. All right, well, that's going to be it for this tutorial. If you have any other questions, put those down in the comments below, and if you want to hire me, there's a link for that down in the description below. And have a good one. Bye.